Welcome everyone. My name is Suyash. I'm your host, and we are. This is our first virtual meetup, and I'd like to welcome all of you, whoever is joining us for the first time and who have been to our meetup before. We plan to do more of these events, and this is a community-run meetup group. We are grateful for our sponsors and our speakers. Today, I'm thrilled to have several very high quality speakers presenting, and I'll introduce them one by one. But I also want to thank our sponsor, Tile, for hosting us. They've hosted us before, and a few people I want to give a shout out to is Crystal for putting the event together, making it happen, and also to Mike. So if we can virtually give them applause. Mike also works at Tile. It'd be great, thank you. Um, or you can do it on your reaction in Zoom. So we'll officially start in 3 minutes, but Crystal, do you want to say anything, logistics, or tell anything to people, particularly about the raffle we're going to do in the end?
Yeah, so hi everyone, I'm Crystal. I will be posting in the Zoom chat a little bit a link to a Google form. All you have to do is just fill out your information, which is your name, email, and if you don't mind sharing your address, because if you do win, then we'll send you the tile. So we have a couple of tiles that we'll be giving out today. We have our Tile Pro, also our Tile Slim, and also our newest product, which is the Tile Stickers. So just go ahead and fill out the Google form, and then at the very end of everyone's talk, I will use a random name generator to pick our winners. So be on the lookout for that. I'll put it in the chat in a few minutes.
Super. So that should be fun. I hope you're excited to enter the drawing. It's not a lot of people, so your chances are good. One thing is that you have to stick around till the end because we would like the winner to be present when we announce at the very end the prizes. Uh, since we have a minute, Mike, do you want to just kind of introduce yourself and maybe welcome the community?
Yeah, I'm Mike Schraubasi. I'm the Director of Mobile Engineering at Tile. I'd like to thank everyone for coming out tonight, and especially our speakers. There's got a lot of interesting topics that we'll be covering tonight. At Tile, we're building some really cool new features, and we're hiring. So if you're an iOS or Android developer, I'll post my email in the chat, and please reach out to me. Thank you.
Thanks, Mike. Yeah, feel free to have a conversation in the chat. You guys can ask questions in the chat, and we can ask the speakers. Perhaps I'll monitor the question, and we can ask them in the end of their talks, so we don't interrupt them, and they can focus on the talks. But please do have a conversation in the chat window. We got a few more people coming in. And let's start. So again, my name is Suyash. I'm your host. This is a community-run event. I do want to share a few things. So this meetup is called Silicon Valley Mobile Developer Meetup. And we cover Android, iOS, all things mobile development. And we keep it highly educational, and we make our meetups free for everyone. And we have done quite a few meetups in the past. And I would like to solicit speakers for future events. So today we have a great lineup, but please feel free to contact me. You can send me a message on Meetup website, or I'll type my email in the chat window, and would love to hear speakers. There are two exciting things in the mobile world right now. One, iOS 14 just came out. And if you're an iOS user, you probably got a notification on your phone or your tablet. And with that, if you're a developer, Xcode 12 is finally out of beta, and it brings a lot of exciting features for you, whether you're interested in machine learning, AR, making widgets, app clips, or if you're a watchOS developer, Apple also introduced the watchOS 7 with iOS 14. On the Android world, some news. Android 11 is out, but it limited to certain devices, especially the Google Pixel lineup. And if you're a developer, you can Flash if you don't have it already, and you can download or update your Android Studio and play with the APIs and make sure your app works on Android 11 or and learn about it. So those are exciting things that are happening. I do plan to cover a talk in future around machine learning on the edge, and we'll have some speakers talk about mobile, how to optimize ML for mobile experience. But today we're excited to have really high quality speakers. And the first one is August, who's a software engineer at Insulet. And he's going to talk to us about testing, integration testing. We want to get you guys ready and prepared for best practices around mobile development and leadership today. So I will stop my screen share and I'll let August take the stage. We can give him a virtual round of applause and help introduce himself.
All right, hey everyone. Can you guys see my screen?
Yes.
How about my mouse? I just want to make sure you're seeing my top screen. I think I'm sharing the wrong one. Oops. Try that again. Here we go. Okay. All right. Just double checking. You can see the integration testing slide. Is that right?
Yes.
All right. So thank you. So, all right, hey everyone. My name is August. I'm an Android engineer. I work at Insulet Corporation. We do medical devices for diabetes patients to help regulate insulin levels. And this is my talk on integration testing, is sort of what I call the forgotten layer of testing in the Android stack. There's the pyramid where we have unit tests on the bottom, and then integration tests, and at the top, UI tests. And the level in the pyramid signifies how many of those tests theoretically we should have for our applications. So get into it here. Yeah, so about me real quick, I started as a freelance web developer in 2016 and discovered Android by accident on a contract for one of my web clients, and really enjoyed it. So pursued it as a career, and now I'm currently at Insulet, working primarily on instrumentation / integration testing for their medical device equipment. And so I wanted to open things up real quick with this quote that I thought was really powerful, and I think it sums it up pretty well, the case for testing, and especially integration, instrumentation testing, because if you think about the way a customer uses your application, it's usually not like they're pulling up the application to use a specific function or a specific service in the application. Nobody says, hey, I'm going to pull up so-and-so's app and use the crash log export service. So, right, they pull up the app and they're using the app. And so when we're testing the apps, we need to test it from like full feature point of view. And so that's the case for integration testing. And I'm going to go over a few different topics, just brush through the pros and cons, when to write integration tests, which is not all the time. There's a time and a place, of course, and some of the quick tools that Android provides for doing this. And then I have a demo app prepared, and I can show you some of the tests that I would write for testing a certain situation. So yeah, so integration tests, for those that don't know, are sort of a layer on top of unit tests. So once you have a bunch of units that are well tested, and you want to start testing the interactions between them, you can write integration tests that would cover those interactions. So in Android, we have activities and services, which would be a good example of some individual components that would be unit tested, right? And even within activities and services, you might have other dependencies on classes that should be thoroughly unit tested, and that would make sure all of their methods and the things that you do to interact with each of those components works properly. And so I think a lot of developers, at least at our company, have a really good grip on the unit testing side of things, and which is great because unit tests are very important. But when it comes to like the activity starting to interact with the service, or you know, this is just an example, but any real interaction between components that are unit tested, you can see from this diagram that the unit test doesn't really capture that interaction itself, which is the arrow. So any actual interaction, you have to figure out a way to write an integration test that would encapsulate that interaction itself. And of course, all tests are important. It's not enough to just write integration tests, just like it's not enough to just have a bunch of unit tests. So in theory, like I said before, according to the pyramid, you want generally more unit tests. And then once you have a sufficient amount of individually tested units, you can start testing the integrations between them. So I have a couple little just toy classes here, which represent a tire and an engine, which would be parts of a car. And so these are good examples of things that you can unit test. Right? You can test that this rotate method of the tires works as expected. You can test that after a certain point, the tires are going to need air. Just like with the engine, you can test that the fire pistons method works, and you can test that the needs fluids method works. So these would be the case for unit testing these individual classes. And then also you can still test unit test classes with dependencies. For example, the car has dependencies on tires and engine. And so there's various ways of doing this, but you might mock a tires class and an engine class and run some unit tests on the car with those mocked classes, which is great, and that works. And so you can unit test all of these classes just fine. And so my theory is testing individual car parts is important, but if you want to actually test driving the car, so which is the whole system actually working together to be the feature, you're going to have to figure out some way to test this sort of in real life, which is where the integration testing comes into play. So on Android, there's a couple major times, I guess, when I am choosing to write integration tests. So like I said before, after units are well tested of a feature, you want to test all the interactions between them. That's a good time to write an integration test. But also when features depend on the Android framework. So if you're doing anything with like Work Manager or navigation components, or you're trying to test something that depends on Android to do the job, you're most likely going to require some kind of an integration test to handle that, so that it runs on the Android framework instead of just like a Java or Kotlin class. So a feature, again, is just some integrated classes that work together to perform some task, right? So you might have a whole bunch of classes with dependencies, like tires and engine on a car, and they're working together to drive, which is the feature in that example. So once you have a feature set up, you're probably going to, at some point, wrap it in maybe a service or some kind of object that delegates to the individual classes, so that whatever your higher level architecture components don't have to interact with directly. So in this example, you just have like a wrapper, and it provides this start complex process for result method. And so whatever user-facing parts of your app are generally going to trigger that feature with this with this method, and it's going to sort of kick off that feature to start running in the background. And so, again, I just wanted to say that it's important that all of these little classes on the left are unit tested, but when you actually want to test the feature itself, you can basically write tests that just trigger this complex process method, and you really, in theory, shouldn't have to know anything about what's going on in each of those units. You should just be able to test the feature itself, and you can test different inputs on that feature. Which is great also, like integration testing is great, and although it's not how users interact with the feature, right? So users are clicking on a button in the app, and that button is going to trigger some UI logic that then, if everything works out, is going to call whatever method to your feature that you're trying to test. And so integration testing isn't always enough either. And I like this diagram because I think it sort of gives a good representation on the different layers in the testing pyramid. So you have the unit tests, which are testing each of the individual components, and then once you have sufficient amount of those grouped together, you're going to test that integration by testing the start complex process for results method, and you can feed different inputs in. And then you obviously still want to test your UI interactions, your UI logic. So when a user clicks on a button, you still want to make sure that it does the appropriate things. Maybe it has some animations, and then it should provide some result too based on what's going on at the lower level. So I just like this diagram because I think it sort of gives a good visual on all that. And then, yeah, again, so when behavior depends on the Android framework, like using navigation or storing things locally or interacting with any of the hardware components, it's generally not going to be enough to write unit tests that are very effective, because you're probably going to be stubbing out a bunch of things. And so if you can have access to the Android framework to test those things, you're going to have a lot more close to reality tests. So just a couple of the tools, I'm going to brush over these kind of quick, because if you read some of the documentation, you can find all of this stuff, but you got to have an Android runner to be able to run your tests on the Android device. And this is the thing that's going to allow you to have access to the Android specific components. And you'll see that you can get a context really easily, and you can also trigger an activity to start. So all you have to do is use this Android JUnit runner when you write your tests. And then as a side note, instrumentation tests go in the Android test source directory as opposed to just the normal source directory. There's also one for just pure unit tests, which don't depend on the Android framework, which would go in just the test folder. But all of this stuff is documented on Android. So if you're writing integration tests or anything like that, just go look it up. And then make sure you use the right dependencies also, because there's been a lot of changes over the last couple of years here. So to get a context, if you're using the Android runner, it's pretty easy to just call the get application context on the application provider class. And instantly you can access things like shared preferences or do anything else that requires a context. So that's one of the major pain points in just pure unit tests, is like how do you get access to a context if you're having to do anything with like shared preferences or anything that requires it. So for this example, we're able to get a handle on the shared preferences and then call this update logged in user method, for example, to store some username in a shared preferences, and then we can verify instantly that that username was saved in the shared preferences, and we just do it twice just to make sure. And also activities. So just like getting a context is pretty easy, the Android framework also gives us this activity scenario rule, which will execute before each of your tests and give you sort of a fresh activity scenario, so that you can then call any of the methods of your activity class and have it actually execute within a real instrumentation environment. So this is different than calling a bunch of stubbed out mocked methods from your tests, because this will actually be running a real activity within a real Android device. And so you can do things in your app process that you wouldn't be able to do just with unit tests. So in this example, we're just calling this method do something important right away. And what that'll do is it'll actually call that method within the activity. It'll do whatever under the hood that the activity method does. And then we can also check some setup variable directly from the activity as well, right within our tests. I wanted to also talk a little bit about Espresso and the differences between what I'm sort of demonstrating and just writing pure Espresso tests. Espresso, for those of you that don't know, is basically a framework for writing just pure UI tests. It's really easy to perform clicks on the Android devices, and it's good for simulating real users interacting with the application. But it doesn't have a whole lot of it doesn't give you much access to what's under the hood. It's sort of limited to, like, click on this and do this from the user's perspective. And my argument is that pure UI testing can sort of be overkill if you have a bunch of inputs that are required to test different variations. And so we'll see some of that in my demo real quick. But yeah, just some of those examples from the last slide, like navigating to a specific section of the app over and over. So if you're doing something that you want to test different inputs to a scenario, but you find that in order to input those variations to the scenario, you have to do something repetitive that requires a bunch of user interaction. It might just be easier to write a pure non-UI test that sort of gives you the ability to skip past all of that and just get right to testing the variations, whatever feature. So we'll see that in a sec. And actually, yeah, back to this diagram, I think it kind of helps to visualize if you're doing things on this right side of the dividing line that cause the UI logic to run over and over again before you get to test the sort complex process for result on the process wrapper. It seems like sort of a waste of time to just be running all that UI logic over and over again if you don't have to. And so with integration testing from a non-UI perspective, it gives us sort of the ability to skip right over the UI logic and just manually insert whatever our inputs are into the feature. So there's definitely advantages of UI testing, which are that it's easier in general. It's easy to just say click on this button and do whatever the user would do in the situation. You don't really need to know how anything works under the hood. And it's also really easy to follow in the code and readable. You don't have to set up a bunch of stuff. There's definitely advantages of it. And then, of course, on the other side, there's like what I talked about earlier, which is it's expensive and sort of slow to run over and over again these UI tests. You also don't have very much control under the hood. And so with non-UI testing, you get the ability to control the actual activity that's running. And so therefore you have access to all of its methods. You can check its internal states. And it just gives you a lot more flexibility. And of course, it's faster because you're not running all that UI logic every single time. And then on the other side of that, there's the disadvantages, which are, of course, greater complexity. When you're not limited to just clicking on buttons, you might actually have to know a thing or two about how the system is working so that you can set things up properly for your scenarios. And sometimes that's hard to do. But this quote I also wanted to include because Espresso is a tool as well as the application provider is a tool, and all these different tools that Android gives us. So it's easy to get caught up in like, oh, I'm writing an Espresso test or I'm writing a pure integration test. But at the end of the day, we're given a bunch of tools, and so we can mix and match as needed to perform whatever test we're trying to do. So it's not a crime to use Espresso to click on a button and then test an interaction under the hood with a more integrated approach. and that's totally doable. And so generally, though, you want to stick to having less UI tests up at the top, and the reason is because it's more expensive to run them. Whereas you can test a lot of integrations very efficiently without UI testing. And then at the bottom, of course, unit tests run super fast. They don't require any dependency on Android, so they run in a fraction of the time. Okay, so I have a quick example testing a little login scenario that I made. This is just your basic login scenario where someone's trying to log in. You have a server and a network, and users should be able to proceed, of course, only with valid account credentials. If there's no internet connection, or if the company servers are malfunctioning, there's going to be some kind of problem, so we're going to need to handle that in some way. And the way that we're going to handle that is just by notifying the user why their login failed. So it would be one of two reasons. And I have this little demo right here, so I'll walk through it. It's pretty simple. Basically, I have these little toggle buttons to control whether the network is connected or the server is responding, just to simulate an actual network request. And if you try to log in with both of those off, it's going to warn you right away, bad network connection. So you can fix your network connection, try again, and it should say that the server is not responding, whatever your servers are down. So you call your team and they fix that, and then you try again. And this time it should work, and it also toasts at the bottom whatever your username was when you logged in. So that's the app. In this kind of a application, we can just discuss what needs to be tested, and of course it looks like a lot when you really map everything out. There's a lot of different things that could be happening. I mean, this is a simplified version, but you have all these different scenarios on the left. The network, as you saw, could be not responding, or the server could be offline, or any of those combinations. And then also after that, you could type in a invalid credential and still get a problem. And so you have this sort of map of what needs to be tested, which if you were running a UI test for every single one of these scenarios, it would be pretty expensive. It's easier, I should say faster, to test just what needs to be tested from the UI's perspective, which is, you know, just the login, and maybe making sure that the spinner is working and making sure that the error message is displayed. For the rest of these, you can sort of dig right under the hood and write integration tests. So just taking a quick look at the code, you have this login fragment. Switching to presenter. Basically, you have the login button, and when you click on it with the username and password, it's going to call this login method, which will delegate to the view model's login method. And it's going to set some little variables just to show that the spinner is loading and everything, and then it's going to call this authenticator.authenticate method, which authenticator is just it's a singleton object that I have just to simulate sort of some network service that you might have. And the authenticate method basically launches this method that is just sort of like a simulation of an actual API running. Right now I just have hard-coded username and password, but in your real-life applications, this might delegate to some more complex service that has a bunch of different dependencies and classes, which would need to be unit tested individually. So we're assuming that all of this works from a unit perspective really well. This authenticate method takes an authenticate callback, which we have specified right here in our view model. So if we succeed with the login, then one of the things we do is update the logged in user in the shared preferences, which is the test that you saw earlier. And then we also notify the UI that it was successful. And then, of course, on failure, we basically do the same thing, but we just update it to a not logged in status. So that's the overview of the app. Let's look at some of the tests, if I can find them. So here's pure instrumentation version of testing this app. You've got the activity scenario rule, like I talked about earlier. And in your setup activity, we're basically getting a handle on the main activity just from this activity scenario. And so once we have the main activity, we can do things like getting a particular fragment that's loaded up on the activity. And there's actually various methods of testing fragments in isolation as well. For the purposes of this, I just went with demonstrating that you could get it just by calling the support, accessing the support fragment manager. There's no way to do this from a unit test perspective because, you don't have any access to any of these methods as part of the Android framework. So it's really cool that you can do this with integration tests. So once we have that handle on that login fragment, then we can call any of its methods, which of course login is one of. And so here we're just setting those variables on the front, these little toggle methods to true. And so we're testing that if everything is good, if we're online and the network is connected, if I do type in a correct password, we should be successful. And same thing down here. If you type in a wrong password, then it should not work. And so what we can do is actually check, like I said, this state of our main activity. So main activity has a little method that just checks if it checks the authenticator for being authorized or not. This is just like a super dumbed down version of checking authorization, but it is an example of state, which can be checked in an integration test. It's hard to do this from a UI perspective if you were just writing pure espresso tests. So these tests run pretty quick, and I just wanted to show you how fast they run as compared to UI testing the same scenario. So it should load up the app, and it's going to use the runner to call these different methods. And it should complete pretty quick. So there's the first one, and the second one. So in total, it took 14 seconds to run those two tests. The first one took 8 seconds. The second one took 6 seconds. So I want to go back and run these UI tests, which uses Espresso to test basically the same thing. And so just to contrast these, here, instead of actually calling the login method, we're clicking on login after typing in the username and password. And so this sort of methodology is limited to just whatever the user can do. And then in order to verify, instead of checking a state, we're actually just checking that we made it to the destination. So did we make it to the home page? And then we're doing the same thing for wrong password. So give these tests a run.
August, we have 1 more minute.
Hopefully. Perfect. So you can see that these are actually typing out the username and password every single time, and then clicking login. And that sort of logic of typing things in, we completely bypassed in the integration test because we were able to just, hopefully you guys can see this still, but we were able to just hard code the username and the password and just insert that right in. So we saved a lot of time on a small scale, but when things scale, you can see how the integration tests would be faster, not by much, but in the long term, it adds up. So it's a little demo there. And in summary, just to wrap things up, I think that integration tests are definitely lighter than UI tests because you don't have to do the same UI logic over and over to test a bunch of similar functions like logging in with different variations. But at the same time, all tests are important, and I guess I just hope that this gives some sort of a perspective on when you should write integration tests versus just pure UI tests and performing clicks on views. And so, yeah, that was my talk. I hope you guys enjoyed it.
Very nice. Thank you very much. Virtual applause for August. Yes, thank you. We can take questions real quick, few questions. Please feel free to unmute yourself and ask anything, or you can type it in the chat.
Yeah, thanks for asking me to speak as well, Mike. I appreciate the opportunity.
Absolutely, great talk. There are
So I
two.
see someone asked the percentage of integration tests. I guess I don't have a good answer for that, but it should be different also depending on the different types of apps. So if your app has a lot of UI logic, and there's a lot of different variations in the UI logic, it makes sense to have a higher percentage of UI tests than what you would normally have for a different type of app that is doing a lot of background stuff under the hood. So I guess it depends on the app, but in general, the real guideline is just to have fewer UI tests than integration tests and fewer integration tests than unit tests. And I guess the way to say that appropriately is the other way around. So have more unit tests than integration tests and more integration tests than UI tests. And yeah, this is definitely, it's definitely TDD doable for writing integration tests. I actually wrote one the other day. So it's very effective too for when you're changing things under the hood. If you have a solid integration test that captures the feature, then you can comfortably make changes to any of the units underneath the hood and be sure that they will still, as long as the integration tests are passing, you can be sure that you didn't break anything when you're modifying any of the individual units.
Super. I have one quick question. Do you mock services, or do you use real world like backend APIs and services for integration testing?
That's a good question. I wanted to have some more examples of testing a service for this talk. Maybe for a future one I will, but I haven't dug into it too much personally. As far as I know, though, you can definitely use real methods on services. So if you have some feature that's run through a service, you can call whatever methods. Like for example, if you have an activity that's bound to a service, you can just call the activity methods that would interact with that service and assume that whatever under the hood inside of your service is going to work properly because it is running inside of a real instrumentation instance. So, but as far as testing individual services, I guess I would have to do some more digging on that myself to answer that good. A good question, thank you.
Thank you. Let's move on. We have 3 more speakers and all of them are really great talks. So our next speaker is Chris Fu, and I'm just putting up. Chris is a senior engineering manager at Climate Corporation, and he's going to talk about hard truths about mobile engineering, speaking from his experience. Let's welcome Chris.
Okay, can you see my screen?
Yes.
I'm going to present. Here you go. Okay, I just shared the link to my slide deck in case you miss out some stuff. So the topic of my talk today is hard truths of mobile engineering. And as you can see in the photo, one of the hard truths is if you're in mobile engineering, you would have multiple devices. You can't really help it because, and this is actually from part of my collection in the past. And over here is the link to my slide deck. Okay, so I call this the blah, blah, blah slide. Basically, it's just, I'm just put this slide in to say like, okay, the reason why I'm speaking about this whole thing about the hard truths is because I've been around the block for a while. I spent about 20 years in the mobile industry, so SMS and all that kind of stuff. But I'm not going to spend too much time on this. But I just want to say that okay, I was at Yahoo with Mike and JBQ as well when we were part of the mobile team, and I used to run the device farm at Yahoo as well. And if you'd like to connect, just search on LinkedIn for Heming and look for this photo, and that's me. Usually only one entry pops up, so that's usually me. Okay, so in case you're wondering about my accent, I'm from Singapore, the land of the crazy rich Asian. So just to clarify, I'm neither crazy nor rich, but I am definitely Asian. And the inspiration for this talk actually is from this book by our founding Prime Minister, Mr. Lee Kuan Yew. So he was somebody who never gave us, he wasn't somebody to give us a lot of BS. He would actually tell us like, okay, what were the hard truths about, Singapore as a small nation, what are our vulnerabilities and all that. And so that sort of inspired me to talk about like what are some of the hard truths about mobile engineering. So these are in summary what I'm going to cover in my talk today. So first of all, Apple. Whether you like it or not, if you're in mobile engineering, you have to deal with Apple. I was just speaking to Mike yesterday about a little article that I was writing, and he says, I have no time to look at this. iOS 14 came out. So it's like that, right? You have to deal with that. Next is that testing on hardware and mobile networks are still essential, whether we like it or not. And we need to code defensively for mobile networks. The dream of continuous deployment will be difficult to be achieved. And then the next few points are not so much to do with mobile engineering, but in engineering, software engineering as a whole. So I wrote a little article called "Who Should Do Testing?" Therefore, test. And then I'll talk about these points in there. And then quality is going to come from more craftsmanship, not necessarily more testing. And then code reviews lead to good code quality and lead to good product quality. So one of the things that I've been working on over the last 6 months or so has been this thing about engineering excellence. How do we achieve strong craftsmanship best practices? Because at the end of the day, testing is after the fact, right? You're catching. It's like a police force doing enforcement. What you really want is to train your engineers, your developers to write good code, so that you don't have downstream issues, and that your test engineers or your testers are freed up to really find all the nooks and crannies and edge cases that your automation or your code reviews are not able to find. And then lastly, there will always be gaps in requirements. Okay, so the elephant in the room, Apple. So whether we like it or not, and kudos to Apple for actually moving the needle with regards to looking out for customers, the man on the streets. Best interests, things like privacy and all that. Apple has really pushed, moved the needle for the whole industry. Some of us who have been working in the mobile industry remember the time when the telco carriers, were the ones that dictated everything, and then Apple came in and basically changed the whole game. But then for those of us who are in mobile engineering, there'll be times when we're like, oh, Apple, right? And we can expect this to continue on. So things like, for example, moving the goalposts. So things like, I think recently they introduced code thinning, and then they are always Apple is always pushing companies to adopt in-app purchasing. So things like that will happen. I mean, they are moving the needle for the industry. Restrictions. So for example, like your Bluetooth running in the background. So one of the things that I was involved in was evaluating what are some of the contact tracing options for Bayer. So we are a subsidiary of Bayer, the pharmaceutical company, and so we were asked to take a look at what are some of the options with regards to mobile apps and for contact tracing. And one of the things that they have worked with with Google was the exposure notification API, which allowed them to basically allow your apps to run Bluetooth on the background. But previously they did not allow, they don't allow that for your normal apps. So you have to use the exposure notification API. And now with as with 13.7 with the exposure notification express, these health agencies do not even need to build an app. You just need to set up a server and work with Apple and Google on that. So it's already built into the OS. Then next is secrecy. So Apple is notorious for this, right? If let's say they are working with you to have your app incorporated into the next version of the OS, they'll make you sign all sorts of NDAs. You can't even tell your spouse you're working on this particular project, and you will have to go in to one of the offices in Cupertino to work on that. So that's a well-known issue. And then new OS or hardware causing mad scramble. So I know with once iOS 14 came out, most companies who have an app will be scrambling to see if there are any issues, right? Because you can do all sorts of testing until the last beta, right? But it's still at the end of the day, when they GA the OS, you will have to test it because there could be issues that you haven't tested for. And when we were at Yahoo, what we used to do was there was one guy who would actually wait outside the Apple store in Palo Alto just to get to buy the new iPhone. And then what we would do is we would circulate across all the app teams to check to make sure that our apps were working fine. So things like that, we have to deal with. And then toolchain updates, this is also quite common. And also the App Store approval and guidelines. Sometimes they are not that consistent, that, but it is what it is, right? By the end of the day, one thing great about Apple is the fact that they have full control over the hardware and the software stack. So things like the ECG monitor on your Apple Watch, the amount of calibration that's needed for that, right? Only Apple can do it. You can't. It's very, very challenging to do it on Android. And similarly, I have a friend who does voice, has a voice training app for iOS, and they don't want to do it for Android because it's just too much work. And then, of course, there's also the highly desirable nature of Apple products, right? So there was this very funny story of this guy in China who proposed to a girl using 99 iPhone 6s, I think so. Cost him a bomb, but sadly he was not very successful. But it's highly desirable. So testing on hardware and mobile networks are still essential. For those of you who are interested, you can, so I gave a talk on my experiences running the device farm sometime in 2016. If you're interested, there's a bit.ly link for that. In summary, whether you like it or not, simulators and emulators represent only idealized hardware. So how the screen, the CPU, GPU, and sensors work together are still quite important. And then you have to deal with, sometimes there's bloatware by OEMs. And one thing that what I found a lot of mobile engineering teams are not doing is to test on low-end hardware, because sometimes, doesn't mean that you have to release for that hardware spec, but when you test on low-end hardware, a lot of issues show up. So like for me, what I like to do is to make sure that my teams test on for iOS an iPod Touch, and then for Android, you can always go to like Walmart to find these like low-end, cheap, under $100, maybe even under $50 Android phones. So yeah, so that's what's that. And then also, you also need to understand like what networks your users are on. So like for us, at Climate, we are in the digital agriculture space. So what some of the concerns that we have are like, out in the farm, what sort of networks are our users running on, so that we can build in the capabilities like, okay, if they need to upload data, they go home and upload the data on Wi-Fi, so things like that. Okay, need to code defensively for mobile networks. So you have things like Bluetooth drop connections, and then also like 4G is dropping down to 2.5G because of lack of signal. So basically, what this means is that some testing is needed before a new major version release. So whether you want to use network conditioner or some other tools to vary the network. That is very, very useful as well. But then, of course, the more cost-effective ways to use beta testers and to really exploit these observability and telemetry tools like your New Relic or other telemetry. Even like your crash management is sort of telemetry tools already. So I added this photo for your interest. Because I thought it was interesting. So this is actually a photo of Qualcomm's 5G radio prototype in 2016. So you can see it's probably a 2U case. So you just imagine that has been reduced to a chip by now. I just thought this was interesting to share. Okay, so continuous deployment will be difficult to achieve for mobile. Why? Because first of all, you have your App Store submission that takes a few days, especially for iOS. And then because of people like me, I don't like to update my apps once it's out. And I usually turn off my auto updates because I generally like I'm generally a creature of habit, so I like to use what I have. So recently, I don't know if you noticed, Facebook updated their web UI, and that annoyed the heck out of me. But that's the reality, right? Our users do not necessarily want to update their apps. So what it means is you have to do a lot more testing pre-release, and then you have to exploit these observability and telemetry tools, as well as phase rollout. So I added this photo because I thought it was funny. Every year, or at least every few years, Apple will just make fun of Android because the adoption rate for the OS is usually takes a lot longer because there's also the whole update cycle that the OEMs have to follow. So Apple, being in full control, are able to push the updates a lot faster. So that's again another hard truth, right? That's one of the nice things about Apple. So next is, okay, so this is not so much mobile engineering per se, but general engineering. And you can find out the article that I wrote in the bit.ly link down below. So again, these are some hard truths, right? Based on my experience. Test automation is more efficiently written by developers. Test engineers, this is my own personal opinion, test engineers need to be more technical. If you're working on mobile, at the very minimum, you need to know how to write a simple app. Commodity tests can and should be outsourced. So commodity tests are things like your localization, testing for localization, as well as device testing. So if, let's say, you want to have a bunch of folks doing exploratory testing on multiple devices, that should really be outsourced. And also, lastly, is try to get comfortable with observability and telemetry, because that is a real force multiplier. And this is, so okay, I grouped these few points under what I call engineering excellence. So the first point being that quality is going to come more from craftsmanship, not for more testing. And I think I mentioned this earlier on. Testing is actually after the fact, and you really want to catch the issues up front. So there is a very interesting story. I call it the rubber hammer story. So this is from Simon Sinek's book, Start With Why. And he talks about this situation when a number of these American auto executives visited Japan, and they visited a Japanese auto factory. And one thing about American auto assembly lines are that at the end of the line, there will be one person who will have a rubber hammer that taps the doors to make sure that they all fit. What the American executives realized was that wasn't the case in the Japanese assembly lines, and so they asked the engineer, like, why don't you do that, right? And the engineer basically said, well, we design and we build it so that the doors fit. Okay, so instead of doing something after the fact, build it such that you don't really need a whole lot of testing down the road. Next is good code reviews lead to good code quality, lead to good product quality. So on the right, you'll see a little a graph or little chart. So this is actually from Smart Bear's 2019 State of Code Reviews. Can't quite see. And this was a survey. They asked quite a number of companies what was the number one thing the company can do to improve code quality. And the top two are code reviews and unit testing. If you notice, functional testing is number 6. So so a lot of people also believe that with good code reviews, you can get good code quality. And last point is there will always be gaps in requirements. I mean, all of you, you're seasoned developers, right? There will always be gaps. And this is a challenge that I have, when you get a user story, do you really know what you're supposed to be building? Sometimes you don't, right? And so how can you clarify the requirements before building or at least tackling the user story? And it shouldn't be just the test team that cares about this. If you are building the feature, you should at least put in an attempt to know what is it that you're expected to build. Okay, so the last slide that I have, so I felt that most of the slides above were kind of like negative or quite a little bit depressing. So I wanted to say there's some stuff on the horizon that actually gives us some hope, and it's also kind of a shameless plug for me because I run the AI in testing and testing AI meetup group, and we have been exploring and getting folks in the industry to talk about some of the stuff that they're doing with regards to using AI and machine learning for testing and DevOps. So some of the things that I felt were interesting to mention are things like bots that are used in functional automation. So Nimble app has this ability to crawl your Android app to look for crashes. And then there's test.ai. They're looking at making the automation a lot more robust. So let's say if you move your button or you change the color or whatever, it still knows that, yeah, it's the right button to press. And then there's Sophie.ai where you can record your test and then it figures out how to run it properly in multiple devices. And then there's deepcode.ai who have an intelligent code review tool that checks your code. Basically, it's like a static analysis. Unfortunately, it does not have, it does not cover Kotlin or Swift or Objective-C yet. It does support Java though. Better ways of measuring functional test coverage. So for those of you who do not know, if and this is my own personal opinion again, and I might be crucified for saying this, but when a test manager tells you we have 100% functional coverage, right? You should take that with a pinch of salt. And I'm not going to go into why, but there are reasons behind it. And I'm actually writing a little article on that. But there is this company called Prod Perfect, which is actually, they have a very novel way of calculating functional test coverage, which uses click streams. But unfortunately, it's not for mobile, it's for web. But the ideas that they have there, I hope at some point some startup will come up with a better way for doing this for mobile. And then again, this is not nothing to do with mobile, but more on server side of things. Harness has an intelligent rollback, continuous deployment platform. So basically what you do is you hook up your APMs like your App Dynamics and your App Dynamics and New Relic or Sumo Logic. So when the user traffic somehow falls in a certain way, in a certain manner, then the platform will auto roll back for you. So that is the end of my talk. And I'm open for questions.
Great. Thank you, Chris. Let's give a virtual round of applause. We'll take some questions. Quick questions anyone has, please unmute and ask. Type it in the chat. All right, I'll ask a question. If people are still thinking. So you had an interesting slide about who should write test. What is the answer to that? Should it be developers or should it be test engineers?
So that is a good question, and I recommend you to read the article, number one. But the conclusion that I had was it should be a collaboration of both, because developers definitely are more efficient at writing test code. Okay, but test engineers are usually better at finding good tests, right? So that cooperation and that coordination could actually be very beneficial for the entire team.
Right. And that was interesting to see that AI has entered the area of testing. Is looking at these tools, how are they putting them or presenting them? Are they, who is the audience? Is it test engineers, or are they trying to remove the the testing people and show that this can be done fully automated?
That's a good question. That's a good question. So to answer that question, I like to use this analogy that I have called the Roomba analogy. The Roomba analogy. So who likes to vacuum their apartment or their house? Nobody does, right? So with the Roomba, you can just let the little bugger run around and just vacuum all over, right? But it doesn't quite catch all the dust, right? Or all the things that it needs to capture, right? And so you still need to go and clean up certain troublesome spots. So it's the same with test automation. So AI and test automation, right? If you have something like a bot that finds all the known crashes, right? Then your test engineers do not have to worry about those cases. They can actually be spending their time writing better tests for more complicated stuff, right? Say for example, if you are if your Android app has some C++ code, say for example, those are very challenging to test, right? You will want them to figure out, like, okay, at the JNI layer, what do you want them to test, and so on and so forth. So let the test engineers focus their efforts on more challenging stuff than rather than the just looking for crashes or looking for bugs that could be easily found by a bot.
Great. There are a few more questions coming up, Chris. Maybe you can look at them in chat and type them up. Let's
Yep.
go to the next speaker in the meantime, and let's put our hands together to welcome Josie from Tile, and she is a senior product engineering director there, and who's going to talk to us about scalable services. So that's a very hot topic, and very excited to have her.
All right, awesome. Hi, everybody. Thank you. All right, let me get a moment here to share my, Chris, if you could stop sharing, that way I can start sharing. There we go. All right. Did you guys see my screen?
Yeah, we see the whole, all of your computer.
Oh, I know. Hold on. I did not want that. I wanted to just share that. Okay, there you go. All right, so welcome. I'm the Senior Director of Platform Engineering here at Tile. So I actually work on integrating our Tile technology into all of our partner ecosystems. So some of the recent projects my team has worked on is we enabled Google Homes to directly ring tiles. We launched the first tile-enabled laptop with HP back in January, and we recently announced a partnership with Intel to empower Intel-enabled laptops to behave as tiles. And so my team works on all of these integrations. I also lead diversity and inclusion at Tile, and after almost leaving the tech industry in early 2018, I've really been on a mission to keep other women in tech. I've been working in on large-scale consumer tech for 20 years now. Been here at Tile. Prior to this, I was at Apple, where I worked on Siri. I managed the music team during the development of the HomePod, and managed the Apple TV Siri team. And we actually got a technical Emmy for that integration while I was managing the team. I live here in Silicon Valley and was very happy there was a blue sky yesterday and today after 4 weeks of smoke. So that's a little bit about me. Some of you may have thought I was going to give an engineering with empathy talk, because it looks like some of the things I was giving that talk. I actually have a recorded version of that talk, so if you did think I was giving that talk, please reach out and I'm happy to send you a link to that. But today I'm going to actually talk about Tile. And so I actually wanted to start with Tile's mission, which is really creating a world where everyone can find everything that matters. And this really excites me because I really care about helping others. And I love the fact that, the only reason we're collecting data is really to empower our users. We don't sell our data. So we really are on, a mission to help our users. And we're really solving a universal problem. So it turns out that you actually spend an average of 15 minutes a day looking for lost things. And that actually adds up to 365 days over the course of your lifetime. And, there's $47 billion worth of lost items every year. I've been late to work looking for my keys before. 80% of people have been. And then the interesting thing is people are actually putting tiles on everything. We actually have people put tiles on turtles and pigs and horse harnesses. It's actually really impressive, the stories we get of what people use to track with their tiles. And, so how does Tile work? So Tile is a little Bluetooth device, and I'll show you a picture in a little bit of our Tile products. And it allows you can put a tile on something and you can find that item from our mobile app. You can double press on a button on a tile and that'll allow you to find your phone through something we call reverse ring. You can look at the map and see the last place seen where your tile was seen. And then finally, what I really want to talk about today is our finding network, right? And this is what really makes Tile special, right? And, our community is helping everybody else in the community find their lost things. And, earlier I was saying people put tiles on everything, right? And, some of the quotes I love is people say, hey, Tile saved my marriage. I've had multiple people actually tell that to me. I actually sent a friend of mine a tile from my quarterly allotment, and she messaged me the day she got in and was like, I've now heard that tile ring 4 times from my girlfriend's phone. Thank you so much, because you've made my life much easier. And so it's great seeing how Tile can positively impact people's lives. And, like I mentioned, people put tiles on everything. So the most popular things to be tiled are keys and wallets, but people put them on turtles, pigs, drones, you name it, it might have gotten tiled. Somebody put a tile on their mask. Actually, they have a favorite mask they've been wearing, and so they've tiled it, which I thought was cool. And so I mentioned I was going to talk about our tile lineup, and so here it is. We have our Mate and our Pro, which last year we put in user replaceable batteries for our tile products, and so, sorry, 2 years ago, and then this last year we actually expanded the range on them. And then we had our brand new products from last year, which is the upgraded Slim, which is now credit card size and just fits right in your wallet and has a 3-year non-replaceable battery. And then the Tile Sticker, which is small and you can put on your remote or anything else, and it's also got a 3-year waterproof battery. And so, I mentioned the Tile devices and the mobile apps, and that's just part of our Tile ecosystem. And so, the ecosystem is made up also of lots of embedded devices and access points too. As I mentioned, my team worked on enabling the first HP laptop to behave as a tile. And then, we've worked with Comcast, and a number of Comcast set-top boxes actually scan for tiles and send us location updates. And we also have our premium service, which allows us to do things like smart alerts that actually will alert you if you've left your tile behind. And so this is actually a picture of the Tile network from, when Tile was kind of started, right? And so the idea is there's lots of users that have the Tile app on their mobile phones, and they're scanning for any tiles they see nearby, whether it's theirs or somebody else's. And anytime they see a tile, it'll send us the location update up to our community, up to our Tile services. And it's anonymous, but that's how the community can really help each other find lost things. And so let me go into details about how this might work. So let's say Megan, back in the days when we were traveling, went to New York to visit her friend Jane, and she accidentally left her keys, which were tiled back in New York. She ends up in San Mateo and is like, I have no idea where my keys are, and looks at her phone and says, the last time they were seen was in New York a while ago, and she marks them as lost. The next time Jane or anybody else in the tile community happens to walk by Megan's tile, the app will send us a location update for Megan's tile. Megan will then get a push notification saying, hey, your tile is actually found at this location by somebody in the tile community. And so Megan knows now, hey, yeah, my tile and my keys are actually definitely in New York. And so how does the tile architecture work? Well, when you get a tile and you buy it, it's actually not advertising because we don't want it to run out of battery while it's in the box, and we also don't want anybody to activate it. And so the tile is in what we call shipping mode. And so when you buy a tile, it says, hey, install the mobile app, and you go through our new user process. And that process says to push the button on the tile. When you press the button on the tile actually starts advertising a certain UUID, Universal Identifier, which is specifically for activation. And the mobile app is scanning for that Bluetooth advertisement for 1 minute. And if it sees it, then the closest tile it sees it's advertising that, it will start a handshake to kick off the activation sequence. So it sends a message up to tile services saying, hey, I'm activating this tile. And then if it's a partner tile, it actually will generate a tile ID and an auth key at that time for that tile, and then we will activate the tile. Once a tile has been activated, it will start advertising a different UUID, which is FEED, and most of our tiles actually advertise every 2 seconds, and they'll pretty much continue to do so until their battery dies. And so I talked about BLE, which stands for Bluetooth Low Energy. And so, you know, a lot of people don't know a lot about how Bluetooth actually works. So I wanted to go through a little bit of an overview of Bluetooth Low Energy and how it works. So Bluetooth Low Energy is actually a subset of classic Bluetooth and was part of the Bluetooth 4.0 specification. It was pretty much designed as a low power consumption way to send small amounts of data. At the time, both Apple and Samsung adopted it very quickly, and so it actually became pretty ubiquitous, and that's why there's billions of BLE devices available today. And so, as I mentioned earlier, there's this concept called advertising. And so when a Bluetooth device like a tile is advertising, it's actually, and this is what actually makes it low energy, it's not actually advertising all the time. It only advertises for a small amount for every advertising interval. So the tile, which is the peripheral in this case, advertises every 2 seconds. The central, which is the phone or an access point in our case, is scanning for a certain amount of time and then stops and then scans again. So the scanning frequency has to line up with the advertising interval for the phone to be able to find the peripheral. And so that's how advertising works. The second thing you can do with Bluetooth Low Energy is a connection. And this is how you're actually going to be exchanging data between the central and the peripheral. So first, as in before, there has to be a scanning process for the central to find the peripheral. And then once they've found each other, there's a connecting process, and then there's a connection interval. And so the connection interval is how long the two devices wait before they send a little bit of data back and forth. So they're aligned on sending data to each other while it's connected. When a Bluetooth device is connected, it actually stops broadcasting and advertising. And so we actually started, when we started Tile, our phones actually stayed connected to all of the tiles. And a little bit later, I'm going to talk about how one of our recent architecture changes has actually been moving more to a connectionless model and how that's impacted mobile and why. And so I wanted to talk a little bit about GAP, which is the generic attribute profile, which is actually how the data gets sent back and forth when the connection takes place. So the attributes are actually the short amounts of data, and pretty much it defines how the data is organized and exchanged. So each attribute has a unique identifier, which is a UUID, and it's transported and defined as characteristics and services. And so characteristics you can think about as like unions of pieces of user data along with the metadata that describes them. And characteristics can actually be thought of as kind of a type analogous to a class. So, and then a service is a collection of characteristics. So for us, we have a tile service, and then we have a number of characteristics within there that we can use. And so it's really a client server model for sending the data between the central and the peripheral. And so at Tile, like I said, we use GAP, but instead of using it directly, our firmware team created a transport called TOA, Tile Over the Air API. And we created this so we could have security and authentication. So it allows for communication between the phone and the tile using that client server pattern I mentioned. And we have defined 2 GAT characteristics that we use for sending and receiving data. And so we have one that lets us use for sending a notification, and then another one for responding to that notification. And so we use GAT write without response as well as GAT notify. And so here's actually a picture of showing kind of how that handshake works on connection. And so, you know, the first thing that BLE has to do is actually discover any characteristics before it can actually try to use them. And once you discover them, you can register for notifications on them. And then you can actually trigger reading the tile ID off of the tile or doing any commands. This is also how we do firmware updates, is over the connection, as well as ringing happens over the connection, both securely. And then, you know, I mentioned, you know, we're going to talk about scalable services. So this kind of leads up to the scalable services part of our conversation here. And so, you know, services is our backend. We ran on Amazon, so this is on AWS. It's a 3-tier REST API. So we have a load balancer tier. We've got application load balancers for most things and an elastic load balancer for our events. Then the middle tier is our services layer. And so this is where really the bulk of the code is. And so our services are really divided up into 5 smaller subsections that the load balancer balances against. So one server manages our Alexa and Google Home traffic for our voice responses. One handles retile, which is our ability to purchase tiles at a discount after a year when your battery has run low. Our API service is all of our main services outside of location. So this is fetching tiles, fetching users, fetching clients. Location is actually our largest just single service. We get around 1.5 billion location updates per day. We store the last place seen in Redis, and then we store a 30-day location history in Aurora to power our premium location history feature. And then finally, our event stream is actually JSON events that are mobile apps and our window app sends, which is, you know, when users click on the app, Bluetooth diagnostics, etc. And we actually get around 33 billion events per day as well. And those just get stored in S3. And so I mentioned location updates, and so I wanted to dig in a little bit about how we made this really scalable, right? And so our location updates are really a multiple producer consumer problem. And so we have the load balancers getting all of these location updates. And then we have a number of nutty worker threads that are processing them. We want those to be very quick and return to the clients as fast as possible. So very little happens in those worker threads. They pretty much just validate that it's a proper tile ID and proper request. At that point, it actually returns back to the client, and most of our location update processing happens asynchronously. The nutty worker threads actually add the location update up to a ring buffer. And so this is actually a pattern called a disruptor. And so it has multiple consumers. We've got 8 consumers that are actually consuming off of that ring buffer and storing it into Redis. And then this picture actually duplicates itself. And there's actually another ring buffer that reads off of those consumers to store it in location history as well. And so this is how we've managed to scale to support as many location updates as we do. And so, what are some of our other challenges that we really are tackling? Well, on the data engineering side, we're really looking at, data quality and visualization, right? When you get so many location updates from phones, hey, those come from GPS. But once you start talking about access points, those might be user configured. How do we start validating those location updates? So that's been a pretty interesting challenge and something we might actually start adding maybe some machine learning around, which is pretty exciting. On the mobile side, we've built our own Bluetooth layer. We had to figure out how to do smart alerts and figure out how to do separation alerts. Our Siri shortcut actually requires 3 inter-process communications between Siri and our Tile app, so we can actually know and show in the app that Siri is ringing your Tile, right? And then we also run our own direct e-commerce site that handles a lot of our, revenue. And so that's its own team that, in some companies, that would be the whole team of engineering, and yet that's just a small part of it. And so, what's the future vision? And so I had shown you that picture earlier. And so here's really where we're going, right? And so you see people with the Tile mobile app, but it's not just tiles anymore, right? We've got those orange circles, which are the access points, as well as, we've got tiles embedded in everything from laptops to headphones these days. And it could be in more things like backpacks and skateboards and more. And so, I've talked about the connectionless earlier. And so I wanted to talk about, here's one of the big architecture changes we actually made in the last year. And so one of the things that as I mentioned, when we first built Tile, the app stayed connected to the tiles. And we did that because that made it faster to ring when somebody wanted to ring their tiles. This caused a problem, though, with other audio devices like AirPods, especially if you had multiple tiles. And actually, as I mentioned, if you stay connected, it's not advertising anymore. So in the case where we have access points trying to scan for tiles as well, they actually wouldn't see the tiles nearby. We also have to figure out if once we went to connectionless, hey, now we have that reverse ring functionality. How do we wake up the phone if we're not connected? So this is actually some of the big challenges we've been solving. We actually finished rolling out connectionless. It took us about a year. It's actually pretty interesting because we have to roll out our firmware across all of our products, and then as well as slowly roll out the changes on mobile to support these things and actually see how it works. We can only do so much testing. We actually have to do a lot of testing, through slow rollouts of experiments to ensure things really work at the scale of our users. And then the other big project that we're working on is really private tile ID. So currently tiles could technically be tracked by their MAC address or via the tile ID, which you can read by connecting to a tile and read it. And so we wanted to make tiles completely secure and have the device not be trackable. So instead of having the tile ID that can be read, there's a hash tile ID in the advertising packet, and we're going to be using that for identification. This actually ended up being a benefit for access point partners because they actually no longer have to connect to read the tile ID to send us a location update, and that can actually help with battery because every time you have to connect to a tile, that actually uses battery. And then also it meant you could actually see more location updates because you don't have to connect to get a location update. So those are some of the side benefits of moving over to this, but from a protection perspective, yes, we're going to be putting the hash tile ID in the advertising packet. We have a big identification service we have to build in the back end that pretty much stores all of our hashes, and eventually we're going to start rotating the MAC addresses on all of our tiles to ensure that they can't be tracked. And so the last thing I want to talk about is a little bit about what I've said my team's working on, right? And so, we're working on things like voice assistant direct ring integrations with, we have the Google Home and Comcast integrations now with PCs. I'm really excited about the Intel integration and enabling, a software-based solution to allowing laptops to behave as tiles. And, we're really expanding into lots of true wireless headphones. We just launched a couple months ago our Skull Candy headphones, and it's great because you can actually even track them when they're off, which is something you can't do with AirPods, just FYI. And anyways, that's it for my tile talk. This is my contact info if you want to reach out to me. And yeah, you can also email me at josie@tile.com. And that's it for me.
Thank you very much, Josie. Let's give a round of applause. Virtual, you can put reactions on Zoom. Quick question, anyone? We have a few questions, Josie. If you want to take one or two.
Yeah.
And, yeah.
Let me see. I will share the link with I can share the link with the tile presentation. So the August question is, how similar is tile implementation to the GATT spec? So we actually use GATT. We don't modify GATT. We just have our own characteristics that we use on top of GATT. So it actually uses just the regular GATT service. And then how do you do testing for all these services? That's actually an interesting one. So recently I actually started using Bespoken to do my voice testing, which has been helping there. They're actually a voice testing service. My automation QA on Windows actually has automated, I think, like 85 or 90% of our Windows testing through automation there. And so it's actually, each team kind of has their own testing, and then we actually have a number of manual QA who really help us with the embedded partners, especially because that has to do a lot of hand holding usually with working with each of them, and you can't automate that as easily.
One last question.
One last question. Okay. What happens if you lose something and the person who finds it doesn't have tile? A question I got. So if anybody else around has the tile app, that will end up sending a location update, right? So somebody has to have the tile app for us to get a location update. So. And then if anybody has any other questions I didn't answer, feel free to ping me directly and I will try to answer them.
Thank you again. Yes, you can continue on the chat. I believe Josie will be able to talk to you over chat. So let's welcome our last speaker. And we will, after the speaker, we'll do the raffle. So please stick around. We have Jean Baptiste, who's going to talk, who's a mobile software architect at LinkedIn. And, we all use LinkedIn all the time, so it's very exciting to have him here. And he's going to talk about technical leadership. So which a lot of, I know, technical people aspire to become. So let's welcome Jean.
All right, thank you, everyone. I'd like to thank the attendees for your time, your attention, the organizers for giving me the opportunity, and all the presenters. That was really, really awesome. I'm going to be talking about leadership. Leadership is something that is naturally needed in any environment where you work with other people. Quick summary about myself. I have about 20 years of mobile engineering experience. I've been building operating systems, browsers, and a whole variety of libraries and frameworks. The common aspect between all of those is that I've always built something to be used by other engineers. I've been a coder, I've been a tech lead, an architect, I've been a manager, I'm now a lead architect. Very quick disclaimer, the opinions here are personal opinions. They're not related to my current employer or any previous employer. All right, leadership is an extremely broad domain. I'm not going to have time to cover everything in a single presentation. I'm going to focus specifically on the aspect of leadership that I call getting work done through others. Even then, that is in itself a very big domain. Usually those are discussions that I have in one-on-one environments with people that take multiple hours that we scatter across multiple weeks. And so this is going to have to be naturally a short summary. I'm going to be cutting a lot of corners. Mostly this is to give everyone an awareness of what happens as we grow into leadership roles. All right, the first aspect about leadership that's very important to me is delegation. Delegation is something that needs to happen naturally because all of us, we always end up having more work than we have time for. Even today, we all end up with presentations where we have more content than we have time for. So it's always a challenge, no matter what. The basic principle about delegation, when you have more work than you have time for, is to pass some of that work to others. And that works very well, but that creates a lot of big challenges. In order to be able to pass some work to another person, you need to know and you need to trust that they'll be able to actually handle that work. So what I have learned over the years is that the fundamental aspect about delegation is you need to actually build that trust in order to be able to actually have a channel for delegation. And building that trust happens through close collaborations. That could be mentorship, that could be peer programming, that could be one-on-ones, that could be a whole variety of environments. But that trust is really a very fundamental thing that allows delegation, that allows passing work to others. That is how we can manage having more work than we have time for. Again, we're going to talk about having more work than we have time for again and again and again. One very important aspect once we talk about delegation, there's a risk of becoming a bottleneck. And by that I mean, if you as a leader end up having a lot of tasks coming to you and then you pass all those tasks to others, it still takes time to look at those tasks, to analyze them, to think about them, and then to pass them to others. So it's very easy to become a bottleneck. The key for that is to train others, not just to be able to do more tasks, but to also give them the self-awareness of what they're able to do so that they can actually look at tasks that are incoming and decide what they can and cannot do. So delegation, very fundamental aspect about leadership and getting work done through others. Once you delegate tasks, there's a second aspect that comes into play, and it's the aspect that I call acceptance. Essentially, the work that you have done through others will be done differently from the way you would do it yourself. That's the nature. We're all different. We all strive for diversity in our environments, whether that's education, background, ethnicity, you name it. We're all very different. So we all do the same tasks differently. Even more importantly, when you delegate to a more junior engineer, in a way, the definition of being a more junior engineer is to have less experience, maybe a risk of making a little bit more mistake. So it's very important when you delegate work to accept it's not going to be done exactly the way you would have done it yourself. That is normal. That is what happens when you delegate work. I'm going to go back to the notion of having more work than we have time for. You need to accept that the work's going to get done better than you had time for. If you have somebody spend a day on a task and it took you 30 minutes to pass that task to that person, it only took you 30 minutes. Since you have more work than you have time for, you got something done in only 30 minutes. If you try to do that task yourself personally, writing the code in 30 minutes, I can promise you it probably would not have looked good. A related aspect to the question of acceptance is a question of satisfaction.
Excuse me.
Some work was given to you.
Excuse me, Jean-Baptiste?
Yes.
Are you sharing slides with us?
I am not sharing slides.
Okay.
That gives me flexibility to actually fit the talk into the time that I have. So a third aspect, satisfaction. If you think about the mechanism, some work is given to you, and then you delegate it to somebody else. As a result, the work was not done by you, and it was not the way you'd have done it. Finding satisfaction in that environment becomes a little bit of a challenge. As we grow from junior roles into leadership roles, we take the habit in junior roles to get evaluated on the work that we do ourselves. This is the work that I do, this is how well I've done that work. And it's quite normal in a junior role because this is essentially what the only task that really happens in a junior role. Once you become in a leadership role, work is given to you, you don't do the work, it's not done the way you do it yourself. That becomes quite a challenge. From a point of view of mental health, this is a major risk of burnout. So it's important to learn to take satisfaction as you become a leader from helping other engineers be more productive. This has been the key to me. If I spend 30 minutes helping an engineer so that they can spend 1 day doing a task instead of spending 3 days, I've actually saved 2 days of productivity out there. And that's the sum of my experiences saves those 2 days of productivity, and I learn to take satisfaction from that. So I'm going to go back to the principle of having more work than we have time for. Again, that's a very important thing. You have to learn as a leader to take satisfaction in being involved in a lot more tasks that happen at the same time. You need to learn how to actually take satisfaction in increasing other engineers' productivity. And finally, I talked earlier about the risk of being a bottleneck. You have to explicitly take satisfaction in the efforts you make into not becoming a bottleneck. Whenever you're very careful to make sure that the world around you can keep going if you don't have time for it, this is an actual important part of being a leader, and you have to be conscious of it, and you have to give yourself credit for it. Now, as we have all those mechanisms, we talk about delegation, we talk about accepting the way the work gets done, and we talk about the satisfaction that we get as leaders. There's one last aspect that becomes quite natural. It's the aspect that I call letting go. Again, you have more work than you have time for, and the more you become a leader, the more and more and more that's going to happen. The more you're going to have work that you don't have time for. Sure, you're going to delegate and you're going to learn how to delegate, but the risk of being a bottleneck keeps being here. So you have to keep in mind that as you grow into becoming more and more of a leader and you have more and more work that comes your way, everybody around you also grows. They also become better at their respective jobs. Over time, there will be tasks that come to you because they had always come to you that in fact could very much go to somebody else, straight to somebody else where you don't have to be involved. You have to actually strive to make that happen very explicitly. The time it takes to route the task to other people becomes, again, a big bottleneck. Get yourself out of being a bottleneck, get yourself out of the way, free up that time. That gives you time to grow, that gives other people time to grow. And that's really how you can grow over time. You have to actually let go of tasks that you used to be doing a while ago that now other people have grown under you, around you to be able to do. Letting go is how you grow, is how you have time to work on those tasks that are more and more complex. I'd like to make a specific, give people, I guess, a specific warning here. There's a fairly obvious way to actually let go of pretty much everything you have on your plate. Just change companies. That's obviously, that gives you the ability to have nothing left on your plate. You start from a totally blank slate. But you also have to keep in mind, and has been our experience, the more you grow into leadership, the harder it becomes to actually become productive at a new company. And what I have learned the hard way, in fact, it is far cheaper to put the effort into letting go of what's on your plate today, what's taking your schedule into one company so that you can grow into that company, rather than just throwing everything away and then restarting from scratch. I'm at a point right now where changing companies takes me 1.5 years, 2 years, more than 2 years to actually start to get productive really again. So the more you become conscious about letting go of what's taking your time that you think could be done by somebody else, the more you'll have opportunities to grow in your current environment and to actually become more and more senior, more and more of a leader without having to actually reset the clock again. Now, I know we're supposed to be talking about mobile, and I haven't said a word about mobile yet. So I'm going to talk about really mobile and what it means to be a leader in a mobile environment. Obviously, all the aspects that I've mentioned earlier, delegation, acceptance, satisfaction, letting go, those happen for all engineers. There's something, though, about being a mobile engineer that's a little bit special. And so I asked a question around me, who's a mobile engineer? I suspect from what we've discussed here that a lot of people think of themselves as mobile engineers if they're writing iOS code in Objective-C or Swift, Android code in Java or in Kotlin, I have a different definition. A mobile engineer is anyone whose code is important in any kind of mobile environment. And suddenly that brings an extremely broad definition. Obviously, we have people who build the mobile apps, but we have people who build any kind of web front end for either mobile or in a responsive environment, where obviously that includes mobile. We have anybody who maintains server-side, the APIs, the middle tiers, the backends. We even have everybody who works on data, on AI, because the data that flows out of a mobile device and it gets used by a mobile device is different. So the real conclusion is everybody is a mobile engineer. And trust me, even if somebody tells you, oh, but I only work on web front ends that only display in desktop browsers, my answer to them is, yes, I tether my laptop to my cell phone. I actually work on those very bad networks that come and go, that get super slow. Even if you think you're doing only desktop work, you're still a mobile engineer. What we know about mobile and what Chris expressed very beautifully earlier, building mobile experiences has a lot of unique challenges. And mobile app engineers specifically, and I suspect that many of us here in this discussion are mobile app engineers, we are natural experts at those challenges. This is where there's a wonderful opportunity of leadership for any mobile app engineer. You get an opportunity to actually exercise leadership, not just through delegation, but also through awareness. Your entire environment, you're surrounded by people who actually make mobile apps possible, who might not know exactly what it takes to actually build a mobile app and a mobile experience. Work with them, learn what their problems are so that you can adapt your work to fitting within the problems. Show them the problems that you have so that they have that awareness and they can start to build all the systems around the application that are a lot more friendly to the application. That doesn't mean that everybody must become a full stack engineer. It's very difficult to become a full stack engineer when the stacks are becoming more and more complex with more and more depth. But having a little bit of that awareness and making yourself known as an expert for mobile is also a form of leadership that's very important. I'm going to be stopping that discussion here. I know I've talked a lot and I know people have been just looking at me because I didn't have slides. Thank you again for taking the time to listen to me. Thank you for the organizers for the opportunity. And we can actually have a few minutes for questions and then quickly go to the raffle.
Thank you very much, Jean Baptiste, or JBQ. I guess you go by that. Anyone has questions, please ask, unmute, or type it in the chat. Some people like that no slide presentation. Nice.
So the first question that I see quickly, there's a question about how do you maintain standards of quality while learning to let go and to delegate. Some of it is that acceptance. It's important to learn to look at it from the point of view of eventually what you're trying to achieve, the users, the customer, and asking yourself, is the work the way it's getting done going to solve the problem for the users, for the customers? And so it's important to learn not to evaluate the quality based on how you would have done the work yourself, but about how the result is going to solve the problem. All right, I see a second question. What is a suggested path for an IC to go into leadership? It actually happens naturally. In reality, there's no switch that you flip that suddenly says, oh, today I'm a leader and yesterday I was not a leader. You don't suddenly get a hat that says today you're a leader and that's it, you have to deal with it. It actually happens very gradually. The moment you do a code review and you review somebody else's code, you're a leader. The moment you actually onboard and welcome an intern in your team, you're a leader. The moment you actually start to actually have a discussion with somebody in another team, you're a leader. The moment you actually work with your management so that they explain what's going on in the team, you're a leader. So leadership happens very organically, very naturally, and it's very normal as part of the growth. If you have the awareness of some of the aspects I've mentioned, the delegation, the acceptance, the satisfaction, and letting go, you'll be able to accelerate the process. But it's going to happen naturally no matter what, and it's better to actually know about it and to go with the flow than to try to fight it. All right, two questions that I think are fairly similar. How do you give up control and trust other people, or how to determine when to delegate or keep it yourself? this is part of working with others, working through mentorship, doing code reviews, training others. You need to build a trust that they will be able to do a certain task. And the best way to build that trust is to have seen those people do very similar tasks around you already and to be successful at it. If you try to actually give an engineer a UI task and they don't suddenly succeed, next time there's a UI task that comes your way, you're probably not going to delegate to the same engineer. And if you find that nobody around you knows how to do that, first you're going to have to do it yourself because the work needs to be done. But also you're going to have to be very conscious that this is an opportunity to grow other engineers in those areas so that you don't become a bottleneck. For me, being a bottleneck has always been a fear. So I learned to actually grow people, I teach myself to trust them, and then I actually delegate those things. Question: how important it is it at a higher level to write code versus delegate and help out in architecture and design? Oh, that's a very hard question. I'm going to try to summarize it very much. I believe that every person has a range of abstractions that they're capable of dealing with mentally. Not everybody's got the same range. Everybody's got a range. I have a good sense of what my actual range is. And if you are writing code yourself all the time, that puts a lower bound on what your range of abstraction can be. And that can be putting, because of your range, that can be putting an upper bound on how far ahead you can be thinking. I know that personally, when I'm writing code, I cannot think more than about 3 months ahead. If I have to be thinking strategically much further than 3 months ahead, I have to let go of writing code. My current range of abstraction today at work is about 1/4 to 5 years. I've got a good sense of what's happening 1/4 at a time. Deeper into the trenches, I don't see it anymore. That's too detailed for me, but I have a very good sense of where I want my company to be 5 years in the future. One last question, and then we're going to be wrapping up. Some companies don't hire junior engineers, only senior engineers. Is that a good model? Well, in that case, your most junior engineers might have the title of being senior engineers, but that means that they are overqualified for some of the tasks. So is it a good model? Yes, maybe, because you expect that everybody's got a certain level of independence already and that they don't need a whole lot of hand-holding. But it also means that there are some tasks that could have been done by more junior engineers that have to be done by people who are slightly overqualified for it. And that means that it gets in the way of professional growth, because now you have those tasks that actually drag those engineers down all the time. That kind of stuff happened to me at one of my jobs. And when I was unable to actually grow the team around me, when I was unable to actually grow people around me to help me, this is when I knew I had to actually switch jobs. But this is not a good environment, and this is not a good career move to actually switch jobs in that environment. So I prefer to see an environment that has a more continuous variety of levels, including people who don't have experience yet. And with that, we're going to be going to the conclusion and the raffle. Thank you, everyone.
Thank you very much. Let's give him a round of applause to resume reactions. Excellent. So with that, before we go to the raffle, I want to open the floor to anyone for a quick 30-second announcement. If anybody is looking for a job, hiring, and Mike was hiring, Mike, maybe you can put your email or link again, because if some people join late, they don't see the Zoom chat. Anyone else has any kind of announcement, anything interesting you're doing coming up, any library you're using? Feel free to type it or unmute and say. Stefan, any meetup coming up on Android, Bay Area Android? Somebody was saying something. Please.
Yeah, that was me. Just if anybody who came late, Tile, we're hiring iOS and Android developers. I posted the link there to our job site, and I also posted my email. So please reach out.
Again, before you go away, thank you everyone for coming, and speakers, especially the organizers. And anyone who wants to present, speak, as you know, we're close-knit community on any topic you want to share and practice public speaking on Zoom around a technical subject, around mobile development, library, a project you did. short presentation long, just let me know, message me. I will make it happen. And I know some of you are, maybe in the market. Feel free to message the people who are hiring and get in touch with them. And everyone have a great night.